Welcome back. For the extension activity, I've gone and opened up a project that I've done previously. And what I'm going to do, just to show you first of all what it is, I'm going to run it and then we'll talk through what the activity actually is. So let's see it first. So we have our two hydrogen atoms. They react to produce helium. They come back. And when one of the hydrogens hits our helium, what we end up with is this green atom. This is called lithium. And we also have these little blue circles, these neutrons whizzing about. So if I stop it there and bring everything back so we can see each individual bit. Okay. If you remember from one of the videos previously, I said what we make is a simple model of hydrogen fusion. An ideal situation. You have two hydrogens under the right temperature, under the right pressure, the right conditions. They hit each other, they produce energy, and then as a result they fuse together and helium is produced. Now, strictly speaking, in reality, that's not exactly what happens. If we're simplifying it, then yes, but in reality, there's a lot more steps. It's a bit more complicated than that. And as an extension activity, what you can try is to try and add in a few of these little bit more complicated aspects. So these little blue things, these are called neutrons. And in reality, hydrogen atoms aren't always one proton, one electron, and one neutron. Sometimes they have more than one neutron. And when you get two hydrogen atoms fusing together, sometimes you have a neutron shooting off as well, and that neutron becomes part of this soup, if you want. And the reaction doesn't just stop at hydrogen. Okay, you can expand this and call it nuclear fusion instead of hydrogen fusion, because in reality, in the heart of stars, for example, hydrogen aren't the only things that fuse together. Hydrogen and helium can hit, and again, in the right circumstances, they can fuse together to produce the next element, that which would be lithium, with 3 electrons, 3 protons. And again, sometimes you'd have a neutron coming off as well. And again, if we're talking in real terms, then these atoms would get bigger and bigger and bigger. That's how all of the different elements in the universe have been formed over billions of years. Stars have conducted this process, this nuclear fusion, producing bigger and bigger elements. And these neutrons are actually a very important part of how stars work, because stars take a lot of energy to sustain themselves. And while hydrogen atoms smash into each other millions of times per second, produce a lot of energy, these little neutrons that are whizzing about inside our soup, they have a part to play as well, because these neutrons can hit the bigger atoms, and when they hit the bigger atoms, the opposite of nuclear fusion happens. We end up with nuclear fission. That is, our big atoms split into 2 smaller atoms. And the process just keeps going on and on and on. It's called a chain reaction, until eventually there's not enough hydrogen left to fuse. There's not enough hydrogen left to fuse. There's only big heavy elements, and eventually the big heavy elements, they aren't hot enough, they aren't under enough pressure, they can't fuse together, and the chain reaction, the energy starts to die off, and eventually our stars explode. Now, for the extension activity, we're not going to try anything quite so complicated. In fact, we're not going to do anything new, but to produce our lithium and our neutron, we are going to use what we've already learned to fuse our hydrogens to get helium, and just add in a few extra steps. So what we have is 2 hydrogens hit each other to produce helium. But if our helium touches one of our hydrogens, well, then we produce lithium. And every time these 2 touch each other, or one of these, or a combination of these 3 touch each other, then we get a neutron out as well. Now, because this is an extension activity, I'm not going to go through how to do that step by step. Like I've said, there's nothing new. It's time for you guys now to apply what you've done, what you've learned with our first step with these three. Still have our reaction, nothing really changes there, and see if you can't get lithium to be produced as well. Now, in terms of what lithium looks like, again, color doesn't really matter, but for some reason in my head lithium is green. They have 3 electrons. If you're really going to be a stickler for detail, they're going to be arranged in this triangle sort of formation with roughly the same distance between each electron, and the nucleus is going to be a bit bigger than the helium nucleus. It's a bigger element, it's a bigger nucleus, there's more inside it, which is going to be bigger than our hydrogen, it's going to be bigger than our helium. And our neutron is going to be roughly the same size as our electron. Okay? In fact, in reality, our neutron would be a bit bigger than our electron, but you can add that in, you can change that if you want to. Okay, so there's our extension activity. See if you can add in our lithium as our extra step. If you manage to do that, let us know on the Technicamps Twitter. Tag us with a picture or something like that. And please come back and try some of our other activity packs down the line. Okay, so hope you've enjoyed. Thank you very much, and we'll see you again.